What's up, everybody? Dad Tech TV here, and today my 5-year-old is building a robot, and you can too. Alright, so my son and I had an amazing time over the weekend. He got to design and program his first robot at only 5 years old. He got to learn about electronics, programming, and robotics in this one project. And a lot of that is thanks to Adafruit, which has been such a great company for the maker community. They've also provided the tutorial, which was the base for this project. However, we did change up the way that we coded it compared to the way that they have it in here. So stay tuned to the end of the video where I'm going to talk more about the different pieces that we used to create this project, along with going through the coding to make it work. But first, let's take a look at the fun we had putting this guy together. So the first thing you need to do is that you need to draw the legs down on the bottom piece, and we're going to cut them out. See how they do like circles so they look like those legs?
Yeah.
So we got to draw like that.
Alright.
These are going to be his feet down here. So draw like half circles.
Yeah, but why? Because that's the inside.
Yeah, but they're going to hang out. You see how his feet hang out down here?
Yeah.
That's what we're going to do. You're going to go from here, up and around like that, and up and around like that. You need to make them pretty big.
Like that?
Perfect.
Ooh.
Now what's it say? Now it says we're going to do the same for the arms. So you see how the arms are on the side here like that?
Yeah.
So we're going to draw basically those half circles here also. So out like this.
Okay.
And the same thing on the other side. Cool. Alright, we got arms and legs. So now, I need you to draw a panda face right on here.
On here?
Yep, a panda face.
Okay. Well,
Yeah, you can look at the picture if you want.
these are the eyes and these are the mouth. This is the mouth.
Awesome.
Dad, are you ready to do the rest?
Yep, go for it.
Make his ears. Daddy?
Yeah.
And now what? Dad, are you gonna put the face on?
Yep.
And
You all done drawing it?
yeah.
Okay.
Daddy,
Yeah.
I'm ready. Daddy, I made the whole face.
Good job.
What is the piece of tape
We gotta tape this piece on the back. Can you tape it, please?
on the back of this?
No, onto here. Good job. Now, how far out do we want his face to stick?
How about
Like that?
yeah.
Okay, can you tape the top then? Tape this onto there. Perfect. Does that look good? Is that how we want it?
Yeah.
Yeah, he looks cool. Alright, bud, what do we got here? So you can always remember this.
This is the brain. I forget what these are though.
Those are the servos, right?
Yeah, those are servos. This is the battery and what else?
And then you have your robot back here,
Yeah.
right? So we're gonna make his arms move and maybe do a little something extra underneath his face.
Yeah, so these are the pieces and we need these first.
To make it move, right? So this is the brain that's gonna tell these how to move, right?
Yeah,
And these are
yeah.
gonna be connected to the arms, so that
Yeah, but
makes
like,
them move.
like there's certain ways because the brain makes it move.
Yep. Very cool, right?
Yeah, because that's how the arms actually move, right?
Panda brain. Panda brain, right?
Yeah. And wait a minute. Daddy,
Tracing it? Oh, my big fingers are in the way.
is that it, Daddy?
Yeah, that's good. You did a great job. We're going to cut it out now.
All right, let's pick it up.
All right, bud. So you drew the template. I cut it out. And what do we have? We have the servo in here now, right?
Yeah.
All ready to go. Mounted perfectly.
So now we have the batteries
And the brain.
And the brain.
And I think we have the other servo. We're going to do a small one in the front, right?
Yes.
Okay. All right, little mini servo time. So you got to trace this again for me. You got your marker?
Yes.
We're going to put this right in the front.
Punch. Takaya.
Is this the middle right here?
Yes, it looks like it.
All right, can you trace that one for me?
Actually, maybe. Okay, that's a good spot. Good.
Perfect. Thank you. Now let's cut it out. What do we got? Is it perfect? Did it fit in there perfect?
Yes. So
Yeah.
now we have the batteries and the brain.
Yeah, we gotta hook everything up. All right, we're gonna hook up the servos. So you see these little pieces over here?
Yeah.
Those are the
These-
pins to hook up the servos, right? So you see how there's different color wires. There's
Yeah.
yellow, red, and brown.
Yeah.
We want the yellow to be facing outside.
Yeah.
So all the way where the
So-
numbers are. So let's hook this up. You
So
see?
the numbers are here.
Yep. So let's put that down right around here.
Yeah.
Now let's
here.
try to hook.
And then.
Let's try to hook these up.
Wait a minute.
It's a little bit dark in here because we're inside a box. So let's go here. And you see this? Can you grab this? You see where the yellow is? We're gonna slide it into the
Yeah.
number 2.
Even when you're inside a closet, it's dark.
Push it down.
So this is going to be very hard.
Perfect. And now we gotta get this one way back here. We gotta do the same, but can you put it on number 1?
Yes. So this goes.
With the yellow out. Remember, yellow out. Okay.
Yeah.
Oh, we got it backward. Yep. Oh, perfect. Perfect. Oh, it's tight in there, right?
Yeah.
Awesome. There it is. Now it's all the way in. You did a great job, bud. Look at that. All right, bud, what are we doing now? You can
Now
barely
we're
see it on here, but we have what here?
Fish string.
Fishing line, right? And
Yeah.
it's connected back to the servo, so when the servo turns, it pulls the arm, right?
Yeah, like this.
Awesome. All right, now we're making a cool design to put on the front, right under his face, right?
Yes.
Awesome.
So let's do. 1, 2. There we go.
A Pac-Man, huh? Cool. Anything
Yeah.
else you gonna put on there?
Or it's a heart or a happy
Cool.
face. But let's make it this way because it's Pac-Man.
Why don't you put some Pac-Man ghosts on there and stuff too?
Okay.
We love Pac-Man. Oh, the power pellets. Here. Awesome, bud. Tell me about what we're doing, bud. Is it all ready? Did we make our robot?
Yes, but we still gotta make a cover up over here.
Yeah, we'll make a cover up for that, but what's the robot gonna do?
It's gonna move its arms.
Yep, its arms and what else?
This part moves.
Yep, and we use Microsoft MakeCode to program it, right?
Yes.
So now this little tiny button in the middle right here. Can
Yeah.
you push that? Ah, we got a robot! We got a robot!
That's cool.
Oh my god! That is so cool, guys! Oh my
How
god.
cool is that?
Yeah, when is it gonna stop working?
It's gonna go on forever, but what's it doing?
It's moving its arms and it's moving over here.
How cool is that?
Yeah.
So did we make a robot?
Yes.
So what did we do? We designed it.
Yes.
We configured the brain.
Yes. And inside here we have like all the things and stuff to program it to do.
Show me what's in there. Open it up again. Show me what's in that. Oh, the battery is the brain, and then it's connected to the servos, right?
See all that, and then on the outside of it, you can see it looks like a panda, and things are moving.
Yeah.
Fish string, stuff like that. Yeah. Because this is like what makes a robot work.
Exactly. We're learning all the fundamentals of robots, right?
Yeah.
And one day we're gonna build a real robot out of metal that does things when we tell it to do it, right?
Yeah. But we don't have to make it tall. These kinds of robots are the easier robots.
And how much fun was this?
Cool.
Yeah, very cool.
Yeah. And there's like stuff in the back too. There's like a thing back there that makes it work. You can see.
And now we can paint it if we want.
And that's what's making it work inside of here.
Awesome.
So down here's where you open it. You just have to stick your finger here, open it. But don't get near this if you're a baby. Whoa. What? Whoa, this is not working. There.
Awesome. Oh man, we had so much fun doing that. So now let me tell you a little bit more about the different pieces that we used. I'm actually a subscriber to the Adafruit Adabox, which is a quarterly subscription box where they send out a whole bunch of different electronics and specific products dedicated to what they send you. The most recent box that I got, the Adabox 008, was specific to robotics. The pieces that we used in this actually came from the Adabox that I received. As you heard in the video, we referred to the brain of the project, and that is actually going to be the development board. Development board that we chose to use was the Circuit Playground Express, which is developed and made by Adafruit, and this is a really cool development board. It's got your standard microprocessor on it with USB connection to program it, but it's got a lot of extra add-ons. If you look at their site, you'll see that it has 10 mini NeoPixels, a motion sensor, a temp sensor, light sensor, sound sensor, a mini speaker, everything built in right to this board along with a bunch of other things. So you can really do a lot with this. They market this as something that a beginner can use all the way up to an expert, so you can really grow with this and do a lot of different projects. Now, when you were looking at what we were calling the brain, it looked a little bit bigger than just this one piece. So we actually had an add-on known as the CRICKIT. The CRICKIT, as you can see, is a piece that actually bolts on and provides additional functionality. So what the CRICKIT does is it's more specific to actually the robotic functions. So it adds analog and digital servo control. It adds DC motor control. It adds drive control for things like solenoids, relays, large LEDs. It has capacitive touch and some additional digital input and output. So this piece is really cool, and this is what gave us the ability to actually control those servos easily. The two pieces here made up what we were calling the brain. The first servo that we had was just a standard size servo, pretty decent size, pretty standard that you can find almost anywhere. They come with all the different pieces to bolt on, depending on how you want to connect different devices. Then we also had the micro servo, which is basically just a smaller version of the larger one, and it also comes with the different pieces that you need. The other cool thing is that the CRICKIT actually has the pins set up so you can plug this right in. You don't have to put one pin at a time or solder or anything. Everything is kind of plug and play to make it really simple and really nice for, especially for, doing a project with your kid. So in the actual tutorial that they had, they were doing coding in Python on how to control the CRICKIT, control the servos. Now that they've added different functionality to the CRICKIT, they've also added different ways to program it. So what we did is that we actually used MakeCode through the Adafruit site, which MakeCode is from Microsoft. And rather than actually writing code, it's more visual blocks that you drop into place to do what you need to. So I'm going to show you exactly how we did that. So if you go to makecode.adafruit.com, it's really simple because you don't even need to download and install any software. You are going to download the code to load onto your Circuit Playground Express, but to actually write the code, you can do it right in a web page. So we're going to click on New Project. And the first thing that we need to do is that this gives us the base for MakeCode specific to the Circuit Playground Express, but we also had the CRICKIT. So under Advanced and Extensions, they actually have the CRICKIT extension here now. So we're going to click that. And it's going to actually add a little box up here for us. So over on the right side is what we call the blocks, and this is basically the code. So by default, they give you a forever, which for coders, you know, this is going to be your loop that loops forever. To explain it to my son, it was much easier to say anything that we put in here continues to run over and over again. So within the forever loop, we're going to control the servo, and basically what we want to do is turn it one way and then turn it back the other way. And that's what pulls those strings to move the arms. So within the CRICKIT, we're going to find right in the top, servos, as you can see. We're going to control the servos by setting the angle. So we're going to just pull this over and drop it. We're going to put it right into the forever loop. And we did plug in the main servo onto the number 1 pins. So this is based on where you plugged it in onto the CRICKIT. So we're going to leave this on 1. And then we're going to change this to 180 degrees, so it goes all the way one way. Now we can actually just copy this by duplicating it. And what we're going to do is that we're going to go all the way the other way. But what we really want to do is that the servo, it's not fast enough to be able to work as fast as this code. So what we need to do is that we actually need to put kind of a timeout or a pause in here. So under the loops, if we look down, we're going to see pause 100 milliseconds. Remember, this is in milliseconds. They have made it pretty easy so that when you do your drop down, you can do 2 seconds. For us to get it to go the speed that we wanted, we used 500 milliseconds. So basically what this is saying is that forever, which means over and over again, we're going to take servo 1 and go 180 degrees, wait 500 milliseconds, and then go back to 0 degrees. And what we're going to do is that we're going to duplicate this, and we're going to put it back in here, so that there's another pause before it goes back to the 180 degrees. So 180 degrees, pause, 0 degrees, pause, 180 degrees, pause, and over again. Now, we also put that servo on the front. So you guessed it, we're just going to add another servo. We're going to do the exact same thing, except we're going to do it for pins, the second set of pins, which is where we plugged in the micro servo. And with this one, we're also going to go 180. And what we can do is just duplicate this, put it here. We're going to do number 2. And that is basically all the code that we have. Now, the Circuit Playground Express does have NeoPixels built into it, and the lights are really cool. So what we did is that we actually did add another forever loop over here. And then we went to lights. We chose show animation. We brought this over here. And we changed it. There's a couple different options. We changed it to the comet option, and we set it to 2 seconds. So now on there, you get like a purple kind of glowing, it goes around and around. It's really nice. And that's really all the code that we had. Pretty cool. You can actually click on JavaScript and look at the JavaScript code based on the blocks that you put in there. So you can see, so this is how you can go from beginner to the next level. So you can actually say, okay, I'm going to do my blocks, and now I'm going to want to learn JavaScript based off of how I did that. And then eventually you can go in here and start modifying. So I want to change this from a 500 millisecond to 1,000 milliseconds, which would be 1 second, right? And you can do it exactly like that and go back to blocks. And you can see that it changed to, oh, it didn't actually change here. I got that wrong, but it did change in the other code if you left it there. So when you look at the documentation for the Circuit Playground Express, you'll see that to connect this to your computer and actually get the code over to it is very simple. You basically have a USB cable that comes with the Circuit Playground Express, connect it up to your computer, and then there's this little reset button that you guys can see in the left picture over here, right in the middle. When you hit that reset button, it actually connects it to your computer, and it shows up as another drive or another folder in your computer. And with Windows 10, Windows 8, that'll automatically pop up and you can basically copy the code. So our code here, what we would do is click download and we'll get a file, and that file we would just copy into that folder that shows up. As soon as that file goes in there, the Circuit Playground Express is smart enough to see the new file and it automatically loads the code, reboots itself, and then starts running that new code. And it's that simple. My son absolutely loved this project. So what I'm going to do is I'm going to put a bunch of links down in the description so that you guys can find all these pieces. And I'd love to see what you guys can actually build yourself also. I hope that you guys enjoyed this video. My son and I had a blast doing this project, and we're surely going to do more in the future. So make sure you subscribe to the channel to see everything that we do from here on out.